In this chapter, let us try to understand the terminology of files, accessing files, folders, traversing the folder contents, and reading and writing plain text files. After completion of this chapter, the learners will be able to demonstrate accessing files and folders, traversing the contents of a folders, and validating file and folder paths. And the learners will be able to write the programs to read, write and append the plain text files in order to process the file contents for analytics or modification. In this video, let us learn the file terminology and the Python support to define the file paths, file access, folder access, traversal of folder contents, absolute and relative path, and how to specify these paths in Python script, estimating the file as well as folder content size, and also the Python support to validate the file or folder paths. A file is a collection of the related information on a secondary storage, and each file has two key properties. One is file path and second is a file name. The file path specifies the location of a file on the computer, and the part of file name has got two sections. One is file name or a base name followed by the file extension, and we find the file extension after the period or dot, and the base name is actually the file name, and the file type represents the nature of the contents of that file. For example, a txt refers to plain text file. On Windows, paths are written with the double slashes using a backslash, and in Linux and other operating system we use forward slash. And in order to support these two types of path representation schemes on different platforms, I mean operating systems, the Python program should consider both the cases. And to have the support to recognize these two path representation schemes, we have a os.path.join function. If we pass a string values of individual file and folder names to this function, os.path.join function, it will return a string with file path using correct path separator. That means either if the Python is installed on Windows, then the path includes the backslashes, and in other operating system like Linux, the path is represented with forward slashes. Consider the example. First we import the library OS, and we are interested in creating a path with these three folder names: user, bin and spam. What we have to do is we have to pass all these string values of folder names to os.path.join function, which creates the path using these folder names. os.path.join function is helpful to create strings, that means different strings as file names. Let's take up this code which joins the file names to, that means different file names to the end of the given folder name. Let us say we want to give three different file names: accounts.txt, detail.csv, and invite.docx, which are there in a particular folder, and we want to generate the complete path of including these file names. What we have to do is we have to generate this path by using, for each of the file name that is present in a list. Here we have created a list of file names which are present in a particular folder, and for each of these file names we create a complete path by using os.path.join function. And first string value is the folder name wherein all these files are present, and the second is the file name, second string, and this function will generate the file path of all these files, txt files, csv, as well as word file. Every program that we run on any computer has a current working directory, also called as CWD, and we can get the current working directory as a string value with the function which is also part of OS library called getCWD. This function will return the current working directory, complete path of the current working directory. You can also change the current working directory by using the function called os.change directory, that is chdir. Let us take up the examples. In this example, we use the method getCWD, which returns the complete path of the current working directory, and we can change this current working directory with the method chdir, wherein we have to provide the complete path of the new working directory. And the Python will display an error if you try to change the directory wherein that directory does not exist. While specifying a file path, we can either use absolute path or relative path. An absolute path always begins with the root folder, means a C drive, D drive, etc. And this relative path, which is always relative to the program's current working directory. There are dot and dot folders. These refers to this directory. If you use a dot, it is a shorthand for this directory, and two dots means that the parent folder. Let us take up the example. Let's take up this directory structure. This is a root folder, then we have a first level folder BACON, and FIZZ is a second level folder, and we have a files this way, and assume that BACON is a current working directory. This is a current working directory, and C is a root, which is also a parent of current working directory, and X is a sibling of current working directory, and file name spam.txt is also a sibling of current working directory. And let's see how we can use the relative paths and absolute paths in the shorthand notation. This parent root folder can be represented with double dot. This is the current working directory, parent folder, double dot slash. and absolute path is this. And the current folder dot slash, if you want to refer BACON dot slash, or you specify the full name. And if you want to refer spam is a file which is found in the root. Okay, and what we have to write is current working directory is this parent, that is double dot slash spam.txt. And also if we have a spam.txt within folder X, this is the current directory, what we have to do is, this is a sibling, we have to refer to the parent double dot, and X is a subfolder of the parent, and then spam.txt, and this is the absolute path. This is how you can use dot and double dot shorthands for current directory or this directory, or to refer to the parent folder. We can create new folders with os.makeDARS function or method. In this example, we are creating a new folder under the subfolder, under the parent folder walnut, under its parent delicious, at root folder C. Note that if the intermediate folders are not available under the root node or at the parent folders, then all these necessary intermediate folders are created to ensure the full path exists. We have a os.path module which contains many helpful functions related to files and file names and file paths. For example, os.path.join used to build the paths for different operating systems. And since os.path is a module which is inside OS module, you can also import it by simply importing OS. os.path module provides functions for returning absolute path of a relative path, as well as for checking whether a given path is an absolute path. We have first function os.path.abspath of argument path will return a string of the absolute path of the argument. This function is very useful to convert the relative path into an absolute path. This function gives a string which is an absolute path of the argument path, which may be a relative path. The second function is abs of argument path will return true if the argument is an absolute path and false otherwise. The third function is rel path, relative path of two arguments, that is first argument is a path, the second is a start. This will return a string of relative path from start path, that is the second argument, start path, to the path. This is the first argument. This function will return a string of a relative path from the folder, that is there is a path, start path, to the path. And if the start is not provided in the method, then the current working directory is considered as a start path. This arguments can be considered as the location of the current working directory or folder, and the other folder where we want to create the relative path from one folder to another folder. Let us take up the examples. The first example where we create the absolute path for the relative path, that is a dot, a single dot is a shorthand notation for current working directory, and we get the absolute path as this. And if we pass this argument string as dot scripts folder, then the absolute path is scripts under the current working directory dot slash slash. And if you use the argument for is absolute as a string, this return false. This should be a path. And if we replace this with the absolute path of dot, absolute path of dot is this, then it returns true, because this dot is a relative path and this function will generate the absolute path. Similarly, we can have a rel path function which gives the relative path between the start path and the first argument path. And in this case, the relative distance and the path is windows. This is start path and this is the path, current path. Similarly, if you work on this, we get the parent and again parent and then windows. And get CWD gives the current working directory. This example is related to the previously shown the folder structure. That's why we get this answer. Dot dot slash windows as the relative path between start path and the path which is specified in the first argument. The function dar name with argument path will return a string of everything that comes before the last slash in the path argument. Similarly, dot base name of argument path will return string of everything that comes after the last slash in the path argument. Let's take up the example. Let's take up this as a path c colon Windows system 32 calc.exe, and this is the base name and this is the directory name, that is the path of the directory, and this is the file name which is the base name. And if you use this method base name of this path will return calc.exe, and if you use the dir name it returns the folder path from the beginning C till system 32. And if you need both directory name of the path as well as the base name together, then you can call a split method of a string to get a tuple value having base name as well as directory name. Let us take up the example. This is the path of calculate.exe, and if we use a split method of os.path with the argument that complete path returns a tuple with the directory name and the base name. Note that we can also create the same tuple by calling dir name and base name and then placing their values, return values, in a tuple like this. We can enclose these two method calls, function calls, separated with comma and enclosed with parenthesis. Again returns a tuple with the directory name and the base name. Observe that os.path.split does not take a file path and return a list of strings of each folder. If you want to have the list of strings of each folders, then use the split string method and split on the string in os.path.sep like this. If you use this split method with the os.path.sep method, separator method, then it returns a list of strings which represent the folder or subdirectory names. Os.path module provides functions for finding size of file in terms of bytes and the files and folders that are present in a given folder. The method .getSize of file path will return the size of file in bytes. Similarly, .listDir path will return list of all files as well as folders present in the path argument. Note that this function is in OS module, not in Os.path. This is the illustrative example where getSize of this exe file returns number of bytes as well as the list dir of this path, the folder system32, will results in number of files and subfolders. To find the total size of all the files present in a given directory, we can use the method getSize and listDir together. Let us take up the example. Assume that we want to find the total size of a folder system32. That means the size of all files and subfolders present in the folder system32. What we have to do is we have to initialize the total size as 0, and then for each of the file name in the list that is returned from list dir of the given path, we are going to add the size of the file using the method getSize, and this path of this file is obtained by joining the folder path as well as the file name that is obtained with os.listdir. With this small code segment with for loop, we can get the total size of files and folders that are present in a given directory. Many Python functions will crash with an error if the user supply the path that does not exist. To eliminate such abnormal situations, Os.path module provides functions to check whether the given path exists, or even one can check whether the given path represents a file or a folder. The method we have to check the path validity is os.path.exists. This will return true if the file or a folder referred in that path, that means in the argument, exists, and return false otherwise. The path.is file will return true if the path argument exists and the path argument is a file. And the third method is path.isdir will return true if the path argument exists and it is a folder or a subdirectory, and return false otherwise. Let us take up the example. Path.exists of Windows, it returns true, and some made up folder path exists, that means this folder doesn't exist, then it returns false. And is directory for system32, yes, it is present. Is a file system32, no, false. Exe, is it a directory, no, false, it is a file, true. And also you can check whether the DVD or a flash drive is whether it is attached to a computer by checking it with the os.path.exists function like this. If DVD writer is a D drive, then you can always check whether the DVD uh, drive is currently attached to a computer. Let us summarize the discussion. We wrote the Python script to access the files as well as folders. We created new folders by even creating the intermediate folders, and we access the files by specifying absolute as well as relative paths. Wrote a Python script to find the size of a folder as well as the file, and also we tried to validate the file path for the successful access of file contents.